In metal casting, even the smallest defect can ruin a component. One of the most common and dangerous defects is called a cold shut. In this video, we'll break down what it is, why it happens, the consequences it causes, and how engineers prevent it. So what exactly is a cold shut? A cold shut occurs when two streams of molten metal fail to properly fuse during solidification. Instead of merging smoothly, they form a visible line or crack where the flow fronts meet. This weak bond makes the part structurally vulnerable. In simple terms, it's like pouring two streams of liquid that meet, but instead of blending, they harden with a seam between them. But why does this happen? The main causes include low pouring temperature, where the metal cools too quickly before merging, poor fluidity of the molten alloy, making it harder for the metal to flow evenly, interrupted or improper gating design, which splits and redirects flow fronts inefficiently, and sometimes long and thin sections in the mold, where the metals simply cannot stay hot enough to merge. All these factors prevent the streams from bonding into a single, solid structure. The results can be serious. Cold shuts create weak spots and cracks that drastically reduce the strength of the casting. In critical applications, like automotive, aerospace, or heavy machinery, a cold shut can cause premature failure under stress. Even in less demanding parts, a cold shut is often a rejection factor, wasting material, time, and cost. So how do we solve this? Engineers and foundries use several methods. Raising the pouring temperature, so the molten metal stays fluid long enough to merge. Improving gating system design, ensuring metal flows smoothly and without turbulence. Selecting alloys with better fluidity, especially for thin-walled or complex shapes. Preheating the mold to slow down cooling and give the streams more time to fuse. And finally, simulation software like Magma or Procast is often used to predict flow patterns and eliminate cold shut risks before production. Cold shut may look like a simple surface defect, but it signals serious structural weakness. By controlling temperature, flow, and mold design, engineers can prevent it and ensure stronger, defect-free castings. If you found this explanation helpful, subscribe to Silk Robotics for more clean, visual breakdowns of engineering and manufacturing concepts.